My final project, it's regarding a node assistant for this beloved course, Advanced Deep Learning. Imagine if we input 1 week's teaching material, for example, week 8, the drug discovery teaching material, upload and then embedded to large language models. For example, these three models, and then we ask the question regarding the sparse and the dense GNN in drug discovery, make comparison table regarding key features. What would the three large language model answer? So here is the example. So for this question, after the embedding, so LLaMA 2, the answer is like this. It's a little bit lengthy, so both upper and the lower part together are the answer. And at the lower part, it did give a table. Well, this is the LLaMA 3.2's answer. It looks much neater and concise. Well, this is the DeepSeek R1's answer. It looks even more neater and concise. And this is the answer from that Lab 8 notebook. And the lower part, in fact, is a comparison table. And as you can see, in fact, it's not bad, all the three models. And some of them is a little bit superfluous. Now, the idea here is really, we all agree that this is a wonderful course. And thanks all the professors and the TAs leading us went over a lot of material topics. So after this course is over, I think from time to time, we might want to go over, review it to find some specific details or the code example, so on and so forth. AI notes assistant might help. So we upload all these materials and then do the embedding, and then we can start asking question. Pretty much, I think they will provide that help. Now, the question is that idea is practicable? Now in fact, we did this prototype and we found that it is doable. And we choose that this large language model, the LLaMA platform, because it's open source and very efficient platform. It is trained, the model is trained by 1 trillion high quality tokens. It has a lot of series like generate 2, 3, 4, and each generation, they also have different parameter settings from as low as 1 billion to 400 billions above. And each generation, it focuses differently. And the LLaMA 2 usually is very good at the general summarization and code generation, while LLaMA 3 is even better performance. So, and also it provides a very small size one you can download to your local, use even one single GPU. Because for this prototype, we don't have that much computing resource. So we choose this small-sized open source LLaMA model. We also take DeepSeek R1 for comparison purpose. Llama 3 becomes popular for his small size and good performance. However, after tried, seems it's not open for embedding yet. So We're using like Llama 2, Llama 3.2, and DeepSeek R1. The technique used included this large language model as well as different techniques like LangChain, like ROC, Chromer, vector DBs. We use LLaMA tool to pull and running all these large language models as a service as the background. We use Gradle to quickly build some UI, although most of the queries for the prototype were conducted in notebook. Collab is used to develop because my local laptop is not that much powerful. I like to use the GPU on the Collab platform. The sample data is week 8 drug discovery class materials. To compare the response quality, we can use a semantic cosine similarity. We can define the functions and then to calculate the cosine similarity between the model's answer and the standard answer. Overall approach and the steps include we first need to install the LLaMA and then start the large language models as the background. And then we upload the sample data and then do the embedding. After that, we collect all the statistics. We use that 8 questions to test the model, and then we collect all the statistics to do the evaluation. We use Gradle to build the UI. So one issue regarding Collab to use LLaMA is Collab doesn't have the systemd service, so I haven't found a workaround. Fortunately, I found this Stack Overflow site, and I followed it. It works. So after it working, we can pull these 3 models and run it. After start running each model, we say bye to quit, so we can run all the 3 models simultaneously. And it works since they are small. They don't take that much memories. And we can see all 3 models are running simultaneously and 100% in GPU. After that, we'll upload the week 8 all teaching materials, almost all of them, to Collab local and put under a folder named docs. We build a function to load the directory. So whatever file under this directory we loaded, it could be different for file format like PDF, like Word format, like text, TXT, HTML, and IPython notebook, and CSV. So each one we give that a different loader, and then we load it, and then we do the embedding. As mentioned, we're running 3 models, and each model should have its own embedding vector DB. Don't mix that together. And this is the 3 Chromer vector DBs, and then 2 different models. And after that, we can do the test using different queries. Totally 8 questions, and divided to 3 categories. One is summarization for the lecture, for the lab, and then we asked some specific detailed questions. And then we also asked the code generation questions. Simply, we can use 2 level loops to finish. The top level is the model, and the bottom level is all the queries. So at the model level, we embed the document to the model, and then at the lower level, we immediately ask those questions, and then we collect the response information as well as the execution times. And this is one example, question 4, and its answer from LLaMA 2. And LLaMA 3 and DeepSeek R1 also give the answer. And then we save the answer or those response into the CSV file in case we lost the session got restarted. We can just load this one to do the result analysis. Here is the performance comparison between the models. We notice for the embedding time, the LLaMA 2 and the DeepSeek R1 are almost the same, are 110 seconds, while LLaMA 3.2 is way faster, about 40% faster than the other two models. Regarding the question response time, we notice the overall DeepSeek R1 takes most of the time. And the LLaMA 2 is almost one time faster than the DeepSeek. And the LLaMA 3.2 is even faster, about only 25 to 30% of the DeepSeek. To see the quality of the response, we can utilize the semantic cosine similarity. This is the function. Simply we found the semantic model, and then we calculated the cosine similarity, and then we apply this function to the data frame where we collected all the answers, and we also combined the standard answer. So we generated the cosine semantic cosine similarity score for each every response from each every model. After that, we can see the quality-wise, response quality-wise, these three models are really not different that much. Through, if we use that as semantic cosine similarity, they're not different that much. However, we know that LLaMA 3.2 is way faster on embedding as well as the query response. So after this prototype for LLaMA 3.2 are chosen, we can use Gradle to build a quick UI, and you can input your questions and get answers. So to conclude, in fact, the idea notes assistant for this course, the advanced deeper learning, is practical. We already implemented it using the different large language models, the LLaMA language models successfully. So overall performance is not that bad. I would give my subjective score around 75% to the overall response quality of the three models really doesn't differ that much. However, we know that the large language, the LLaMA model 3.2, they are way faster. So that's why we chosen 3.2. The sample data is the wicked drug discovery, and all the files can be embedded to each every model about 1 to 2 minutes, and the 8 questions answers can be come back in 1.5 minutes to 5 minutes. So we do see some more space to improve. If we get a bilateral large language model, if we could improve the text embedding, we can also try to include the image embedding, since we have a lot of pictures, especially in this week 8 teaching material. We can also try to improve the prompt engineering. For now, it's pretty blank. So overall, in fact, this note assistant looks pretty promising. Thank you.